Okay, so I actually ran into a little bit of an infinite loop before. Let me just show you what I had added here. So when I call this step function, what I'm going to do is I'm going to call this nearest neighbors. And again, I was able to control the context here by doing this binding up here on my iterator function when it gets called, and now I'm able to control the context. And what I'm going to do is, once I go here, I'm going to find the nearest neighbors. I'm going to do that. I'm going to pass in my cell. I'm going to split it. And what I'm doing here is I'm getting my x value and my y value. And I'm going to loop over this. And in fact, not only am I going to loop over I, I'm going to do j as well. This is going to be y. This is going to be y. And this is going to be j. And let's just do console.log ij. And if we load this and we click step, we should be getting these three values. Now, let's actually just do a couple of things here. What we're going to do in order to get our neighbors is we'll create a variable called neighbors. It's going to be an array. And when we go in here, we're going to see if we can find the neighbors. I saw that a lot of folks ran into problems where you could deal with the edge case of the board in a couple of different ways. This is maybe it's a little bit inelegant, but I'm going to go over here and say cell equals document get element by ID. And I'll go over here, and this is not going to be E. This will be I dash J. And I'll say neighbors dot push cell. And I'm not going to push. I'm only going to push if, in fact, I have my cell. Now, there's one issue that I'm going to run into here. So this is undefined, and the reason why it's undefined is I need to return neighbors. You get my neighbors by looping over them. And these are my neighbors. So there's a couple of issues that I run into here. We see that some of this looks pretty good. I mean, I only see 4 elements here over in this corner, right? The problem that I run into is that I really don't want to have 0, 0 as part of this. And so what I could do is say if cell, and I'm basically saying it's not the exact same thing as the cell that was passed in. So now at least if I go over here, I could see that I've got only these 3 guys that are here. I've got 4 that are over here, and I'm getting the correct number of neighbors. So here I've got nearest neighbors, and why don't we actually break this up into another thing and actually say nearest alive neighbors. And this is going to be a function. We're just going to do a quick count here in a loop. And we'll say neighbors, we'll pass in a cell here. And we'll say this nearest neighbors cell. And I'll loop I equals 0, I less than neighbors dot length, I plus plus. And how do I know they're alive? Well, I have this nice utility method, and I could say if this is alive cell. So if this cell is alive that I'm passing through, not the cell, but this is going to be neighbors I. So if the one that I'm looping over is alive, I'm going to say count plus plus, and I'll return count. And we'll just do a quick test here. All right, I've got nothing that's alive. And here, I could look and see that I have, let's clear this out, refresh this. So this first one that comes up should say 3 neighbors that are alive around it. Okay. Again, most of these are 0, but you see I've got some 2s and I've got 3s, right? I've got a 2 that's over here. I've got a 2 that's over here. I've got a 2 that's over here, or something along those lines, right? So what I'm going to do now is publish this up so you can take a look at it. So at this point, I've got my nearest alive neighbors. And now I'm going to make a determination what my next step is going to be.